Hey guys, so the question that I'm going to be answering is f of x equals ax over ax squared plus 1. That's the function, the parent function that we're going to be addressing in this question. This function is limited by 8 is more than or equal to x, which is more than or equal to negative 8, where 8 is any real number. The graph of f is shown below, and in this graph, the region between x equals 3 and x equals 7 is shaded. So the first part of this question, part A, asks us to show that f of negative x equals negative f of x. So in essence, what we're trying to show, the IB has told us that they do equal each other, but we need to prove that. So we're going to start by showing that, first finding what f of negative x is, then what negative f of x is. So f negative x equals a times negative x over negative x in a bracket squared plus 1. Because we have to make the x value, which in the parent function is positive, negative. And that can be further simplified to negative ax over x squared. Note that a negative squared becomes a positive, plus 1. So we know that f of negative x equals negative ax over x squared plus 1. Now, the other half of this equation is to show that negative f of x, what negative f of x is, and to prove that f negative x equals negative f of x. So in order to prove that, we're going to find negative f of x. So to find negative f of x, we're going to be doing negative of the whole function, in essence, ax over x squared plus 1. So you know that negative f of x is negative ax over x squared plus 1. So if we look at both sides, we know that negative ax over x squared plus 1 is the same for both f of negative x and negative f of x. So we can then therefore say that f of negative x equals negative f of x. Hey guys, so part B of this question is, given that f double prime x, or the second derivative, equals 2ax times x squared minus 3 over x squared plus 1 cubed, find the coordinates of all points of inflection. So this question has given us the second derivative. And we know that the point of inflection, the point or points of inflection always occur where f double prime x, or the second derivative, equals 0. So knowing this, we can make f double prime x, or the second derivative, equals 0 so that we can solve for the x coordinates of the points of inflection. So we made 0 equal to 2ax times x squared minus 3 over x squared plus 1 cubed. Now we can easily get rid of the denominator by bringing it to the left side and multiplying it by 0, which would then give us, isolate the numerator and make it 0 equals 2ax times x squared minus 3. So now we've got a quadratic equation somewhere. We've got an equation that we know we can solve by finding what all the x values that make the equation equal to 0. So knowing that, we just have to find what the equations are. So x squared minus 3 can be considered a difference of squares, because we can square x and we can square 3. So we can simplify that to 0 equals 2ax times root times x minus root 3 times x plus root 3. So we've got a quadratic equation right there, and we need to find whatever makes the equation equal to 0. And so we need to pretty much find in the brackets and in the equation what the values of x are to make the whole equation equal to 0. So the first x value that makes the equation equal to 0 is putting in x in 2ax, because if that's equal to 0, then the rest of the equation will be multiplied with 0, and that's going to equal 0. So we know that x equals 0. That's the first one. And then we've got x minus root 3 and x plus root 3. X minus root 3 and x plus root 3 in brackets. And we need to make these brackets equal to 0 so we can so that we can make the equation equal to 0. Because when those brackets are equal to 0, anything multiplied will then equal to 0 and the equation will be valid. So x minus root 3, x must equal to root 3 because root 3 minus root 3 is simply 0. So you've got root 3. And now the final bracket, x plus root 3, that would be negative root 3. Because negative root 3 plus root 3 is equal to 0. So we've got 3 x coordinates where the points of inflection occur. Now knowing that, we've got x plus 3, x equals 0, x equals root 3, x equals negative root 3. We need to find the y coordinates so that we can have the coordinates of all points of inflection. So we further go from there and we put it into the original equation, which was ax over x squared plus 1. So f of x equals ax over x squared plus 1. Now we individually put 0, root 3, and negative root 3 to find the answers to the question. So we're going to start with f0 equals 0 times a over 0 plus 1. That's going to simply equal 0 over 1, which equals 0. So we know that the first point of inflection is 0 and 0. So that's number 1. Now we're going to extend the page and find when f of x, what the f root 3 is. Equals, so ax over x squared plus 1. So that will become a root 3 squared plus 1. Extend the page again. Equals a root 3 over 3 plus 1, which equals a root 3 over 4. So we've got a root 3 over a root 3 squared plus over root 3 squared plus 1. Any root squared always becomes the number without the root. So root 3 squared would then become 3. And as you can see, we follow that through in these steps. So we end up with f root 3 equal a root 3 over 4. Now we need to find the final one, which is f of negative root 3. So we extend the page, and we're going to find f of negative root 3. So f of negative root 3, put that back into the equation, equals a negative root 3 over root 3 squared plus 1. Now, that can be further simplified to negative root 3a over, what's a negative root 3 squared? It's 3. So 3 plus 1, the denominator will stay the same when f equals when we were solving for f of root 3, that's going to be 4. So our second y value is f of negative root 3 equals negative a root 3, f of negative root 3. So that equals negative a root 3 over 4. So we go up. We've got a root 3 over 4 for f root 3, and negative a root 3 over 4 for f negative root 3. Let's put the brackets around this. So we extend the page a bit more, and we've got 3 points of inflection. They are 0, 0, root 3, and a root 3 over 4. And the final one is negative root 3, negative a root 3 over 4. Those, gentlemen, are your answers. Thank you.